Hi guys, welcome back to my YouTube channel, Mazatrol Tips and Tricks. If this is your first time here, my name is Phil, and I teach people how to set up and run a Mazak CNC lathe while programming it with Mazatrol. This next video is something several people asked about, and that's how to mill the OD using a right angle tool. I'll show you how to set the tool geometry and how to program a slot. All right, let's get started. All right, this is the tool that we're going to be using right here. This is a right angle tool with a 1/2 inch end mill, and it's got a 3 flute geometry designed for cutting aluminum. So the first thing we're going to do is go over here to the tool data, and we're going to set tool 15, and we're going to go to the tool file. So arrow down to tool 15, and this is a milling angle tool, and it's a end mill, and it's on the outer diameter. And then it says the tool holder type. On this machine, a right angle milling tool is a tool holder 4. Tool nominal diameter is going to be 0.5, a 1/2 inch. The depth of the tool, this is how deep of a cut it can take. And I'm going to get back to this field right here. So right now I'm going to put it at 1 inch, but I'm going to change this field after we program the machine. I'll show you why. The width of the cut is 0.5. The width of the tool shank is 0.5. The pitch, this field isn't used for this tool. The tool length, I'm going to say, is 2 inches long, and the number of teeth is going to be 3 flutes. So now we have the tool file described, and this is find number 15. So go to tool data, and then find number 15 is on station 15. Tool diameter is 0.5. This field right here, this actual diameter, this controls the RPM of the tool. So if this is not set correctly, the tool's going to be too fast or too slow. Nose radius, this tool doesn't have a nose radius. Spindle rotation is going to be the white arrow, and it's a right-hand tool. Again, it doesn't matter for this type of tool. So the next thing we got to do is go into tool set, and we have to set the tool geometry. And the Z is going to be the one we have to manually adjust it, because we're going to probe the edge of the tool, but we need to move the geometry to the center line of the tool. So we need to move the geometry so it's right on the center and not on the edge of the tool. And I'll show you how we do that. So the first thing we're going to do is push tool set measure. That brings the tool probe arm down. And now we can probe the tool. I got a barrier alarm because I had 0 in the tools, so I'm going to push barrier cancel for right now. So bring it over, we're going to probe X, and then rotate the tool until one of the corners is on the tool. Push the down arrow button and then jog it in a downward direction. So we got the beep. here's our X position. Turn off the arrow, move it over to the side of the tool, and now probe the very edge of the tool, making sure that this is the furthest point. Push the left arrow button, jog it in, and now we have our number, but this is not the finished number. So turn off the arrow, move it away from the part, and then turn off the probe. So now what we have to do is we have to add a negative number to the 17.0769. So negative 17.0769 minus 250, which is half of the tool, and we get negative 17.3269. So this is a number that we can write down because all of these tools are going to be in the same plane for this machine. So instead of having to probe the Z every time and then minus or add the tool to it, half the tool, we can basically just type in this number just like we do with the center line of the drills or end mills that are in an axial orientation. So now that we have the tool probed and set, now we're going to put in the material and then start programming this machine. So let's put in the material. And we're going to create a program that's not listed up here. We're going to call it work number 21. Program, Mazatrol. This is aluminum. The outside diameter of the workpiece is 3.25. The inside diameter is 0. The workpiece length, I'm going to say, is 4 inches long. It's a little longer than that, but as long as we're not turning back farther than the 4 inches, the machine doesn't care. Max spindle RPM limit. This is the G50 for the turning operations and not the milling operations. So I'm going to actually skim cut the OD of the workpiece before I mill it. So max spindle is 2,000 RPM. Finish allowance on X is 10 thousandths. Finish allowance on Z is 5. And I'm not going to cut the work face, so I'm leaving that at 0. Turn on the coolant. And I'm going to run tool 16. All right, so basically I'm going to turn back 2-inch diameter, 2 inches on the length. So now what I want to do is start milling it. So I'm going to push the arrows twice. This brings up the milling menu, and I'm going to select the milling groove option. The last 3 options, or 4, line centered, right compensation, or left compensation. For this simple part, we're going to use the milling groove option. So this is basically for doing a keyway or a slot just straight down the middle of the part, and it's not going to give him any option to rotate C. where these other ones we can rotate C and create a helix and other things like that. So again, we're going to select the milling groove option on the outside diameter of the workpiece. Width of the groove is a 1/2 inch. The depth, we're going to say it's going to go 300 thousandths deep. Finish allowance, this is the feed rate for the finisher. I'm just going to run the feed rate at the same rate as the rougher, so I'll leave this field at 0. Finish allowance on the axis direction, so on the X, I want to leave 10 thousandths on the floor for that tool. Surface speed for rough cut, the auto comes up, I hit enter, and it gives me the feeds and speeds. Feed rate for roughing is radial, so that's the feed rate when it's cutting in Z on this particular operation. And the axis direction is the plunging feed rate. It's at 1/2 the feed rate as the traverse feed rate. Roughing tool is going to be tool 15, offset 1. The finish tool is going to be tool 15, offset 1. So the starting point on the radius is going to be 3.2 divided by 2 because these are radius values. So 1.6 is going to be my starting radius, and then I'm going to feed down 300 thousandths from there. Starting point on the angle, which is the C orientation, I'm just going to start at 0. And the starting point on Z, I'm going to say is a 1/2 inch into the workpiece, and that will make the width of the slot, the edge of the slot, a 1/4 inch from the end of the part. From the center line of the slot is what this is programmed with on Z, to the end of the part is a 1/2 inch in distance. Minus 1/2 the tool is going to give us a 250 dimension at the end of the slot. Final point on Z, I'm going to say it's going to go to the end of this, well, I'll go 1.5, and then it'll have a 1/4 inch off the end of this. And then we'll say end, and now we'll take a look at it. So figure check. Push the display mode. And there's the slot. It doesn't show the slot on this side, but it shows it on the end. So now what this is going to do when we run the program, it's going to take one roughing pass for the turning tool, one finish pass, and then it's going to take one roughing pass for the slot and then one finish pass. So let's watch it right now. And there, that's done. I don't want to take 300 thousandths on this machine because the tools are not very rigid, and it's really not going to like that big of a cut. So what I'm going to do is I'm going to take 50 thousandths depth of cut by altering the tool file page. So instead of telling the machine that I have a depth of cut at 1 inch, I'm going to say it's at 50 thousandths. So what that's going to do is take 50 thousandths each pass and nibble at it, and then take 10 thousandths on the final cut. This machine does not have a y-axis, so I cannot control the width of the cut unless I have a smaller end mill for the roughing tool, and then the finish end mill is going to finish the whole thing in one shot. That might be a preferred method for this, but for a training session, we're just going to run it with the one tool. So I changed the depth of cut to 50 thousandths. So now let's go back to the program and let's rerun it. So it's going to take it in 6 passes on roughing, and then number 7 is going to be the finisher. So now let's go ahead and set the Z0 in this program. We'll call it up and then we'll run it. So I'm going to set Z using a turning tool. I don't want to set it using the milling tool because it gets confusing because of that 1/4 inch difference on the Z. So here's tool 16. All right, we're going to call that 0. Z offset teach, 0 input, auto, work number 21, and there's the 1/10 that comes up every now and again. So we're 1/10 behind our 0. I'm going to turn the display mode off so I can see the tool. All right, let's go ahead and run it. And for this particular job, I'm going to actually run it with the door open because I'm only taking 50 thousandths cut, and we'll see how that goes. So I'm going to shut the coolant off and then run it that way. All right, here we go. And there's our part with a slot right down the middle. If you guys like what you see, go ahead and push that subscribe button and click the bell so you won't miss any future videos we have coming out. If you guys found this video to be helpful, please give it a thumbs up. That helps out my channel and gets YouTube to share this video with more people. Also, if you guys have any more suggestions for future videos, please let me know in the comments. Thanks again for watching.